2017 question number 6. Here we go. You are given 3 functions represented in 3 different ways: a table, a graph, and an equation. And you have to deal with mix and matching to some different extents. In the explanation, it does say g is a differentiable function. That is very important because g is given as a table. If they do not directly tell you that a function given as a table is differentiable or is continuous, you have to assume that it is not in everything that you do, or basically assume that it probably is not, I should say. Then it also says h is a function whose graph consists of 5 line segments. So that tells you these are 5 line segments. So when you need to go to find slope, you can depend on the slope of the line segment to go for it. All right, now part A. Part A is really just asking you to find the derivative of f at pi. In order to do that, you first have to find the derivative of f, which is given in equation form. So you're showing off your ability to use all of your derivative rules here. You have a function inside of another one. So you've got a baby function. The mommy function is cosine of blah. Derivative of the mommy is negative sine of blah. The chain rule says to shove the baby in and multiply by its derivative. Then we have an addition. And then we can separately differentiate the next function. It also has a function inside of another one. So the baby function is sine x. The mommy function is e to the power of blah. The derivative of e to the power of blah is, drum roll, e to the power of blah. What? Then baby, shove it in, multiply by its derivative. Derivative of sine is cosine, and that multiplies to the function. Now that you have that done, the next step is plug pi in. And you are expected to solve unit circle trig. Sine of 2 pi is 0. Cosine of pi is -1. Sine of pi is 0. Just trying to color code to make sure that you are clear of what went where. And because of the 0, I'm not bothering multiplying by the -2. E to the 0 is 1, so we end up with -1 is the answer to f prime of pi. Then we're ready to move on to part B. Part B, we are supposed to find k prime of pi. K is given as a composite function, so I need to use the chain rule. My baby function is f of x, and the first thing I should do is just lay out what the chain rule does with these functions. So k prime of x is equal to, and I'm going to circle the baby, derivative of the mommy function, shove the baby in, multiply by the derivative of the baby function. Boom. Next, put the pi in. The AP test often has you use something you found in an earlier part in the current section you are in. If you don't notice that you already found that, in fact, you just found this a moment ago, if you don't realize that, you're going to waste time. So you've got to remember what you have recently solved. It's important to do that. So we just found that f prime of pi was equal to negative, I didn't write my negative, -1. So I can go ahead and put that in. Be careful with your composite functions. You have to first find the value of the inner function. So I need to find f of pi. Now, we haven't actually found f of pi yet. So going back to f of x, I'm going to erase some of this to get it out of the way. If I plug in pi, I have cosine of 2 pi plus e to the power of sine pi. And cosine 2 pi is positive 1. Sine pi is 0. E to the 0 is 1, so I end up getting 2. Now I'm going to go back to where f of pi was, and I'm going to just substitute f of pi with that 2. And then I want to step back and look at the fact that this is now asking me to find h prime at x equals 2. So I'm going to go look at who represents h, and I need to find the slope for x equals 2. So that means I need to know the slope of this particular line segment. You just need to find 2 endpoints of that segment and just calculate out the slope from those other 2 points. So down 1, right 3 means a slope of -1/3. And I get a positive 1/3 as an answer. And that is part B. Before I move on to part C, I'm going to erase a little bit to clean this up. It'll give you a chance to just kind of breathe a little too while I do that. And here we go. M of x, we want to find m prime of 2. You want to notice that the first thing you need to contend with is using a product rule, because you have a first function multiplied to a second function. However, you want to be aware that when you do take the derivative of the g of -2x, that you're going to have to chain rule that when you do go through its derivative. Our first order of business is find m prime of x before I plug in the 2. So with the product rule, I'm going to keep one of the functions as is, multiply by the derivative of the other one, and then add and switch who I keep and who I differentiate. And I've got to be careful, I'm chain ruling. So I have -2x is the baby function, the mommy is g of blah, the derivative is g prime of blah. Give mommy her baby and multiply by the derivative of the baby. So get that all laid out, then plug the 2 in. What number was I plugging? And then I look at what do I need to find. I need to find g of negative 4 and g prime of negative 4. So I'm going to come over and look at g is defined in the table, and I can see that g of negative 4 is 5. The derivative is negative 1. 5, negative 1, 5, negative 1. Then I need to go over to the h function and find its slope at 2, but you may recall that we just found that the slope of h at 2 is negative 1/3. And now I need to find h of 2, but I want to carefully think about the slope of that line and where that lands me here. And with a slope of negative 1/3 moving from this point, that will be negative 1/3, negative 2/3. So negative 2/3 is my value. Now, my recommendation from here is don't multiply and add unless you feel like you're going to risk it. Because if you multiply wrong, you lost everything you just earned. And just leave it there. Call it a day. And if I look at the answer points, I'm going to find that and bring it over to show how much things were worth. For the part that we just did, so basically realize finding m prime of x was 2 points. That was just this statement here without going over to the table and the graph and identifying the slopes and the values that those things gave us. This 1 point is for correctly getting all of these numbers. If you do arithmetic on this train of numbers and you do it wrong, you lost everything you just did past writing out this is what the derivative is. So I'm just trying to warn you to stop at that point. All right, we've got one more part. I'm going to erase and make some room. Okay. Part D. Is there a number C in the closed interval? You know, at that point, you should notice that this is either intermediate or mean value theorem, just with that statement alone. Just with, is there a number C? Now, is there a number C such that the derivative is equal to negative 4? Now, most likely, because it's saying derivative equal negative 4, most likely it's mean value theorem. But I've also seen problems where you actually have values of g prime and you can use the intermediate value theorem instead. So if I use mean value theorem, I have to first set up my hypothesis of that mean value theorem. And that is, you have to be sure that your g of x function is continuous over the closed interval and that g of x is differentiable for at least over the open interval. You have to write both of these down even though they told you that it was differentiable. You are identifying that this is necessary information to use. And then you need to mention the mean value theorem. So because of these two things, the mean value theorem, and you can write MVT, guarantees that there is at least one, let me get rid of my stray mark, at least one C in the open interval such that F, the average rate of change, is equal to the instantaneous rate of change at C. Now, I still need to show that these numbers work, but the mean value theorem guarantees that. Now you need to find out what is f of negative 3 and what is f of negative 5. And wait, I just realized what I did. I changed the name of my function. Because the name of my function is g. So let me fix that. That's an unfortunate easy thing to do when you memorize definitions. Now I know I'm looking for g of negative 3 and g of negative 5. So g of negative 3 is 2, g of negative 5 is 10, 2 and 10, 2 and 10. And then negative 3 plus 5 is 2. So you need to be able to say that this is equal to this, and you have to make this statement. And then this is equal to negative 8 over 2, which is negative 4. And so because that is negative 4, you are guaranteed that there must be some C where the slope is equal to negative 4. And this is a nice mean value theorem problem because it works with the endpoints, with the function that's right there. There are some harder mean value theorem problems out there, but that's a pretty nice one. I'm going to stop this recording.